Hello everyone. Today we are going to learn about quantum numbers. So it's from the chapter 3 atomic structure from chemistry. We are going to learn it so simply that you don't have to even revise before the exam. So at first we have to know the definition of quantum numbers. So what do we mean by quantum numbers? So quantum numbers is defined as the a four numbers set of four numbers which provide the location of nucleus of which provides location of electron in the nucleus. This is the easiest formula, and we don't have to remember more about this. So there are various quantum numbers. So first we have principal quantum number. It is represented by n. So it can be defined as it what the fuck it represents the what does it represent? It represents the cell in the nucleus, or represents the cell of electron. Sorry for bad handwriting. This is how we are gonna study, but you can consult me if you have any queries. So we got the definition. It represents the cell of the electron. We have studied in class 10 or 9. There are four cells. They are K, L, M, N. So K is first cell, L is second cell, M is third cell, and N is fourth cell. It is in the increasing order, like ABCD, like K, L, M, N, O, P, Q, R, S, and numbers are 1, 2, 3, 4, 5, 6, 7, 8. They are in increasing order. So K is the first cell, L is the second cell, and M is the third cell, and N is the fourth cell. So this is the principal quantum numbers. It is represented by N. We already discussed it above. The next is, so before going to next, we have already studied in class 10 that the electrons are present in the cell, like certain number of electrons are present in certain cells. So it follows the 2n square rule. So in first K cell, the number is first. So 2, n means 1 square is equals to 2. L means 2 into 2 square is equals to 8. 2 into 3 square means 18. 2 into 4 square is equals to 32. It is in the increasing order. So in first cell we can only store 2 electrons. In second we can store 8. In third we can store 18, and in fourth we can store 33 electrons. This is for principal quantum numbers. So in second number we have azimuthal quantum number. It is represented by L, like letter L. You can define as it represents the, what does it represent? It represents the subcell in the nucleus. So we already studied in class 10 there are four subcells: S, P, SP, D and F. SP, D and F. So the value of L starts from 0, 1, 2, 3. Like you can remember while studying S0, P1, D2 and F3. So the in this subcell they are mainly present in the increasing order of energy. So S is less like S have less energy than P have less energy than D, and D have less energy than F. So this is the order. So we store electrons in the increasing order, like lower energy to higher energy. So these are the things you have to remember in azimuthal quantum numbers. In third number we have magnetic quantum numbers. It is represented by M. So in this magnetic quantum number, it can be defined as it represents orbitals of the subcell. Represent the orbital of the subcell. So orbitals and orbits are different thing. Orbits where the electrons revolve like this cell, and orbitals means like how electrons are stored. So this is the definition. And S, P, D and F, these are the subcell. We already studied in azimuthal quantum numbers. This is subcell. It is represented by L, azimuthal quantum numbers. It starts with 0, 1, 2 and 3. In magnetic quantum numbers M, as subcells always be 0. The value of S subcell is 0. P, for P it is plus 1, minus 1. You can remember like 0, 0, 0, plus 1, plus 2, minus 1, minus 2. Like you can see this number. So if it has 2, you have to go up to plus 2 and minus 2. If it has 3, you have to go up to 3, minus 2, minus 1, 0, plus 1, plus 2 and plus 3. This is the magnetic quantum numbers, but they are arranged in the number of like in certain orientation. We call it like box. So in S subcell it has only one orientation. In P subcell it has 3 orientation, and in D it has 5 orientation, and in F it has 7 orientation. 1, 2, 3, 4, 1, 2, 3, 4, 5, 6 and 7. Only one orientation and 3 orientation. They are called PX, PY and PZ. I'm gonna tell you later why they are called PX, PY and PZ. And later, and the D shell it called DXY, DYZ, DZX, DX square minus Y square, DX square minus Z square. You can see this in the book, and for this there is no specific number. I hope you got this all done. I'm trying to simplify as simply as possible. The number 4 is spin quantum numbers. It is represented by S. it represents the spin of electron in its own axis. So spin means it can either spin clockwise means upward arrow, or it can spin in anti-clockwise. Anti-clockwise means downward arrow. So the clockwise value is plus 1 by 2, anti-clockwise value is minus 1 by 2. Okay, this is the quantum numbers. Hope you got all right. Let's do one example. I'm gonna read the question and you have to write. Okay, an electron is in a 4f orbital. The electron is in 4f orbital. So what is the possible value of quantum number n? We need to find the value of n. L means azimuthal quantum numbers, m means magnetic quantum numbers, and n means s means spin quantum numbers. So it has 4, so its principal quantum number is 4. Done? Easy? Yeah, easy. And in azimuthal quantum numbers, this is L and this is F cell. So we have read there is S, P, D and F, and azimuthal quantum numbers, it starts with 0, 1, 2 and 3. F is equals to 3, so azimuthal quantum number is 3. And M means the magnetic quantum number. Since it is F, it starts with 3, so it is minus 3, minus 2, minus 1, 0, plus 1, plus 2 and plus 3. So as spin means when are they spinning. So the question haven't mentioned in which direction the electrons are spinning, so we have to write both values. So plus 1 by 2 comma minus 1 by 2 for each value of m, because minus means anti-clockwise, plus means clockwise. I hope you have got this. You have got this right. And next is shapes and orbitals. Orbitals and shapes of S and P orbitals only. Fortunately, we don't have to study about D and F orbitals. For shape, we are going to study shape of S orbital. So S orbital means first, like S means first, its azimuthal quantum number is 0 and its magnetic quantum number is equals to 0, means it has only one value. So S orbital has only one orientation. Like if it is 1s, then this is nucleus and this is electron. If it is 2s, then this is nucleus, this is electron, this is empty space. I'm going to explain it later. And this is electron. So you probably gonna ask, what is this space? It is called node. So what do you mean by node? The region where the probability, LITY, probability of finding or having electrons is 0 is called node. So node is that place where electrons aren't found. This is the s orbital, and next is p orbital. P orbital means its azimuthal quantum number is 1, magnetic quantum number is -1, 0, +1, and yeah, that's it. So since it has got 3 blocks, we have already discussed it, named px, py and pz. It gonna be in the form of axis. So here it is px, so it is in x-axis. X means x-axis, so this is x-axis, y-axis, and this is z. Same for py, it is in y-axis, z, y, x, and for py it is going to be in z-axis. So you probably gonna question yourself, what is this called? This is the nucleus, and this is the nodal plane. What do you mean a nodal plane? Nodal plane is a passing point in which the probability of finding electrons is almost 0. Like this is the plane where the probability of finding electron is 0. This is called p orbital. And this much for today. I'm gonna upload another video about Hund's rule of maximum multiplication of and configuration of electrons, atoms and ions. It's gonna be next part. For now, bye guys.